So I'm going to share, my name is Donghao Huang. Currently I'm working at the Mastercard R&D team at leading the global emerging technology for AI, machine learning, and generative AI. So with 25 years of software development, I hold more than 25 granted patents and a lot of more pending patent file pending, and published 14 research papers. Beyond that, I'm also pursuing a part-time degree in generative AI for enterprise applications at Singapore Management University, which complements my graduate study from AUS, Peking University, and Tsinghua University. The combination of the academic foundation and my hands-on experience in fintech applications enabled me to develop transformative innovations at the intersection of emerging technologies and financial applications. Just to start with how the research starts. So this is the product launched we announced last year in 2020, May 2020 in October, that we call Mastercard Product Onboarding Assistant. And this year in April, our Mastercard has been awarded the 2025 Excellence in Customer Service for Technology of the Year because of the excellent performance of this GenAI assistant for product onboarding. So during the initial development of the GenAI product onboarding system, we observed a very severe problem from the open source large language models. Because when we started, we always used the OpenAI APIs, and which worked very well with our initial code base. But once we tried to switch to open source models, we find out some serious text repetition problem. So let's show the first one is talking about this. When large language try to talk about the Bohr's model, you can see the sentence and the electrons are in a state of energy levels are repeat until for a long time, for long sentences, make the responses unreadable. And the other case here is that you can see repetitive the new lines. If you really switch in the kind of UI experience, you can see the screen go up and up with all blank content. So which will deliver very bad user experience. To address this problem, inference engines like Hugging Face transformers, they do introduce the repetition penalty parameters. But during the experimentation, we realized that it's very difficult to set the right value for the R repetition penalty parameter or RPP. If you set it too low, then you have a repetition problem. If you set it too high, then the sentence might just cut off and become an incomplete response. Either way, you will render the user experience very badly. So this come to the core research problem we try to address. So how do we achieve the balance between reducing excessive repetition while still maintain the coherence and the relevance of the output by the open source large language models? To address this, we developed another metric called repetition-aware performance, while we are trying to balance the repetition and performance in open source LLMs. Let me explain with this example to see how our RAP works. So if you ask a large language model what currency is used in Panama, the model actually output the correct answer, the Panamanian Baloba and the US dollars. But you can see very clearly here that US dollars actually repeated twice, and then also more dots, non-necessary dots here. So we develop an efficient repetition detection algorithm to classify the repetition problem into long word character like the dots, and also the text repetition like United States dollars here. And then eventually we calculate the repetition ratio to define how severe the repetition in the response is. And then we apply a cubic penalty function to the original 100% of accuracy, we get around 25% of rep. So even if the results, initial performance is 100%, it will get down to 25%, so which give us a way to optimize to the RPP values. Later we can see. So to benchmark all the open source models, we had developed, we used the two different modes. One is we tried to use RAG, and we fix the retrieval component and just swap out all the open source models so that we can tell the differences between the large language model for the generation piece, because we don't really care about the retrieval accuracy yet for this specific purpose. And we also try to remove the retrieval component totally, just try to see a direct answer from large language models to see whether the repetition patterns are still there. So we call it the long RAG. So we systematically change the repetition penalty parameters from 1 to 1.3 with the increments of 0.02. This systematic approach allows us to map out the granular differences between the different parameters and across all the models we evaluated. So to evaluate the models, we also use two widely used data set for the natural language processing. One is the WebQSP, which is a widely used benchmark for knowledge-based question answering tasks. We use the performance matrix F1. And another one is from Microsoft Marco datasets. It's a comprehensive dataset for reading comprehension and question answering. So we use the BERT F1 as the performance metric. So the key change, because we know that to fine-tune to get the better performance, we will need to do the prompt engineering. So we also try to run different prompting strategy. The first one is we call it the RAG, generic prompt, which is the default prompt engine. Template introduced by inline chain, which is a widely used open source framework for large language model application development. So you can see it's just natural language without any templates. So when we try to do the non-RAG, we notice, okay, that for each specific LLM family, actually they have a kind of so-called chat template. We need to squeeze the text into the right template like this one. So later we think about, okay, maybe we can also do the same thing. We call RAG chat template, putting all the RAG information into this chat template for different LLM. So we will see whether this RAG chat template will get us better performance. So this is the results. I don't want to get into the detail due to the time constraint, but the very important observation here is that if we can see that RAG chat template will consistently suppress the text repetition 10 times smaller than the generic prompt. So that is the very first observation actually from this research findings. When I talk to our product development team and say, hey, you guys probably need to switch from the default LangChain prompt template to this chat template, and initially they don't really believe so. And then I use their data set and use my methodology and prove that they also have the repetition problem with their current implementation. Eventually, the whole product development switched to this chat template approach. Another observation is that if you use the RPP, normally you will suppress the repetition. You can see the downward trend for almost across all the performance metrics there. But you might also notice that it impacts impact repetition as well as performance. So to get the balance, we need to tune the RPP so that we will have a balance. So this is the way we are trying to do the balance between the performance and the repetition. So the blue color, and it shows that the best original performance, the RPP value, the best. The yellow color shows the best the RPP value for the best RAP value. So if you see just see the first subplot, you can see that at the beginning, for the blue color actually it has around 26% of the repetition ratio. It means a very high repetition. But if we choose the yellow color, the RPP, it changed to the RR change is suppressed to 2%, which is a decrement of 92% of the repetition behaviors. But if you see the performance drop here is just 0.022 points. So with this we can systematically find the balance, the best RPP to balance the performance and the repetition. To summarize, we developed a repetition detection algorithm to measure the repetition in generated text using repetition ratio. This algorithm, I don't have time to discuss the details, but it outperformed the previous versions in the literature by 20% in terms of the efficiency. And we also introduced a repetition-aware performance, which allows us to do the optimization of the large language model while maintaining content quality. So key takeaway here is that use chat template for whatever application you are going to build. We talk about RAG, but in our research paper, we also talk about translation. We also find some same pattern here. And that we could see the difference in RPP where not only impact the text repetition, but also impact the performance. So we need to make sure that find the right RPP so that you don't sacrifice performance while you are trying to suppress the text repetition. So our RIP is introduced a new way to balance the performance and the repetition. All these findings have been published in LACO conference, which was held in US from April 29 to May 4. So you can see the link here also is now publicly available online. Thank you for your attention. If you are interested to discuss more with me, and feel free to connect via LinkedIn or send me an email. Thank you.